In this lesson, you're going to learn how you actually discount the unlevered free cash flows of a company to present value and complete step one of our DCF analysis here. So in the previous video, we went through this calculation of going from Apple's revenue all the way down to their unlevered free cash flow here. And we're almost done with the first part of our DCF analysis. But the problem is that we can't just sum up all these cash flows right here. So if I go in and actually apply the sum function to all of these, we can't just go in and say that Apple's cash flows are worth 75 billion here. Because the fact is that, once again, money in year 5, the 17 billion number here, is worth a lot less than if we had that 17 billion today in year 1 or year 0. So we need to figure out how we actually discount this. Now, how you determine the proper discount rate to use, books have been written on this subject, and it's very, very tricky. For right now, we're just going to go with a very simple assumption, and we're going to say 10% for now. In a couple other videos in this course later on, we'll actually be getting into the calculation for this to see how you would really determine it based on comparable companies and other statistics. But for this part of the analysis, I'm just going to keep it simple so that we can get into the detail on that later on. So the discount rate here is representing essentially how much it costs to run this company overall. So when Apple's management team is figuring out how they're going to expand, how they're going to fund operations, the discount rate for their cash flows represents the interest rate on their operations, on their business operations. And to those funding the operations, the discount rate represents the expected rate of return. So for example, if Apple raises debt and they have a 9% interest rate on debt, the debt investors would expect a 9% return, and their discount rate effectively would be 9%. So that's how you can think about discount rate. From the perspective of a company, it represents an interest rate on their business operations, how much it costs to run the company. And then from the perspective of investors, it represents the expected return on their investment in this company. Now, to actually determine the present value here, there are a couple ways you could do this. You could actually just use the NPV function in Excel and just take this 10% and then apply it to these values. So you could do that. I'm going to do something a little different. What we're going to do here is actually calculate this manually. So we're going to take unlevered free cash flow and then divide it by 1 plus the discount rate over here. And we're going to raise this to the power of the year that we're in. So 2010 would be year 1, 2011 would be year 2, and so on. So I'm just going to enter 1 here for now. So we have that formula. Now, there are a couple problems with this. The first being that we don't want to have this 1 hard-coded. We want to have it somewhere else. So what I'm going to do here is under normal discount period, I'm going to start with entering 1.0 for year 1, and then I'm just going to add 1 to this in each subsequent year. So now we can modify this formula and we can link this part, the power part, to the line below. The other thing we want to fix here is we want to anchor the discount rate with F4 so that this does not shift around when we copy it across. So with that in place, let's just copy this formula across now. And we see, interestingly enough, even though the unlevered free cash flow is increasing each year, actually the year 5 amount right here, the 10.6 billion, is actually less in present value terms than the 2010 amount right here. So that just goes to show you the power of present value and discount rates when it comes to capital and analyzing a company's cash flows. To show you what an effect this has, if we take the same sum formula and just copy it down 1 row, we see that the present value of these cash flows is worth around 20 billion less. So there's a significant difference here, and that's why we have to take it into account when we do this discounted cash flow analysis. One other thing I want to do here is just enter the sum of the present value of cash flows over with our assumptions and output area over there. And that's just for our reference so we have it in the future so we don't forget to add this in later on. So that's a quick overview of how you determine the present value of a company's free cash flows. Coming up in the next video, we're going to look at a slightly more accurate way to come up with this present value by using something called the mid-year discount convention. And we'll be looking at how this differs from the normal discount period that we used here, the straightforward one of 1, 2, 3, 4, 5. And we'll see why it can often give us a better indication of the present value of a company's free cash flows over a 5-year period like this.